Hello there, economics friends. In this video, we're going to tackle a couple of concepts that are tied to the theory of the firm. We're going to look specifically at the production function, and then we're going to look at costs in the short run. By way of the background, we've already learned that every firm has a goal of maximizing profit. And we know that profit is revenue minus cost. The revenue comes when the firm sells the products that it makes. So a firm has to engage in production. We've learned that production is the act of taking raw inputs, those factors of production, land, labor, and capital, and then converting them into the finished products that the firm sells. Now remember, the firm is going to make money when they sell products, but they're going to spend money in order to buy the factors of production required to make the products. So we're looking at money coming in and money going out. In this first part of the day, we're going to look at the production function. And the production function allows us to take a look at how the firm is going to use combinations of inputs in order to make their product. Okay, so let's start with the production function. And by way of an official definition, we can say that the production function tells us how much output, how much product can be made with various levels of input. So we're looking once again with the production function at the movement from inputs into output. Now, we've also learned before about the economic ideas of the short run and the long run. The short run is when at least one variable, at least one factor is fixed or can't be changed. Typically, to make the model easier, we assume that capital, like your factory or your plant or your shop, that's going to be fixed, and that labor, your workers, that can be varied. So the production function is also a short run model, because in this model, we're looking at capital being fixed, and we're looking at labor being variable. Okay. Our assumptions for this model are right here. We're going to assume that the firm uses 1 unit of fixed input. That's 1 unit of capital. That was our K. Let's say that we're making pizzas. That's going to be our pizza shop. We have a lease. We're required to stay in that building for the time of the lease. We can't change that, right? It's a fixed input. So we have capital being fixed. However, we can increase our number of pizzas made by hiring more workers. That's changing our labor input. So we're going to do that. If you take a look at this production function here, we see a couple of columns. We see, first of all, our unit of fixed input, and that was capital. Notice that we're keeping that number at 1 all the way down because it's fixed. Our second column is our variable input, and that's going to be labor. So imagine that we have a pizza shop. We have a lease, so we're stuck in this pizza shop in the short run. We don't have any control over that, but we can control how many workers we hire, how many people come in every day to work in our pizza shop and help us to make those delicious pizzas. So our variable input can vary. We can simply add more people, bring in more workers. Okay. And then finally, we have this one here. This is total product. This is basically our Q. So total product, that's our output. So we see that we're combining capital plus labor to make output. We're combining our pizza plant plus our workers to make pizzas. And you can see the relationship right here. Notice we have 0 workers hired, 0 pizzas. Well, that makes sense. If nobody comes in, we're not going to have any pizzas. Notice as we hire our first worker, As we go from 0 workers to 1 worker, we bring in our first worker, we grow from 0 pizzas to 2 pizzas. And we can see that as we add more and more and more workers, our pizza output is going to change. And that's the essence of production. Now, so far that seems pretty straightforward, but there's a really important concept here. And that concept is marginal product. Now, you recall from earlier lectures that marginal means next or extra or additional. So the marginal product is the extra pizzas that we get from hiring extra workers. That's the key. The marginal product is the additional amount of product, the additional amount of output that we get by hiring additional workers. The formula for marginal product is the change in output divided by the change in labor. You recall that that triangle is the symbol delta. That's our symbol for change. So what we're asking with marginal product, as we add 1 more worker, what do we get out of that extra worker? As we add a second worker, what do we get from that worker? And marginal product is the real key to the production function. The real question that a company is going to have to answer is how many, in this case pizza, how many pizzas should we make? And the rule that we're going to follow is we should only make additional pizzas if the price that those pizzas bring in is greater than what it costs us to make them. In other words, we're going to follow the rule of marginal benefit and marginal cost. We're only going to produce more pizzas if the benefit of each extra pizza is greater than the cost. Okay? But to do that, we need to figure out how much money those pizzas are going to bring in. And since total revenue, we learned, is equal to P times Q, this column here, output, is really important. Production is the essence of our revenue because whatever we make is what we sell, and that's our revenue. And revenue is the first big piece of profit maximization. Okay? So let's go through this. Now, the rule is you can never have a marginal product on your first line because there's nothing that was changed. We have 0 workers, we're getting 0 pizzas. But now let's say that we add 1 worker. That worker brings us 2 pizzas. So what we could say is the change in quantity was equal to 2. We went from 0 pizzas to 2 pizzas. And the change in labor was equal to 1. We went from 0 workers to 1 worker. So when we divide that, because again, our formula right here was that the marginal product is the change in output divided by the change in labor. For this first worker, we're going to get an output, a marginal product of 2. The first worker, in other words, is going to generate 2 pizzas. And it makes sense. We had no workers, we had no pizzas. We brought in the first worker, now we have 2 pizzas. So that first worker, their marginal product, their additional contribution, the extra pizzas that that worker brought in is 2. Now, what happens if we hire a second worker? So we go from 1 worker to 2. Well, if we do that, we go from 2 pizzas to 5. Interesting. We go from 2 pizzas to 5. Now, we can look at this in a couple of ways. One way would simply be really common sense. We had 1 worker and 2 pizzas. We brought in a second worker and went to 5 pizzas. So it kind of makes sense that that second worker, that their marginal contribution, that they generated for us 3 pizzas. But let's see if it works out with our numbers. The change in quantity, we went from 2 to 5. So the change in quantity is 5 minus 2, or 3. The change in quantity is 3. The change in labor, we went from 1 worker to 2. So 2 minus 1 is 1. And therefore, the change in quantity divided by the change in labor is 3 divided by 1, or 3. So the marginal product for the second worker is 3. And this should make sense because, again, when we only had 1 worker, we only had 2 pizzas. By adding that next worker, we got a total of 5, going from 2 pizzas to 5 pizzas, that's 3. Whenever you're doing marginals, you're basically subtracting because marginal means change. So you're taking the new value, subtracting it from the old value, and that's the change in amount or the change in labor. You then divide those two, and there you go. Let's do one more real quick together, and then we'll just fill the rest in. We want to add a third worker. So we currently have 2 workers making 5 pizzas. Now we want to add a third worker. What does that third worker bring us? Well, we can see here that with 3 workers, we go from 5 pizzas to 9 pizzas. So with 3 workers, now we have 9 pizzas. Not bad. What's the marginal contribution? What's the marginal product of that worker? Well, it's going to be the change in Q divided by the change in L. The change in Q, we went from 5 to 9. So the change there is going to be 4. The change in workers, we went from 2 to 3. So that's going to be 1. So the marginal product for our third worker is 4. And this is basically how you do it. If you go through the rest of this, you're going to see a pattern emerge. And we'll do actually one more together to show you that pattern. So you're running your pizza place and you're saying, this is going great. We've got 3 workers. We're making 9 pizzas. Things are looking pretty good. What if we hire a 4th worker? So we go from 3 workers to 4. What does that 4th worker bring in? Well, if we go from 3 workers to 4 workers, if we increase our labor from 3 to 4, we increase our pizzas, our output, from 9 to 12. What's that contribution? Well, the change in quantity, we went from 9 to 12, so we gained 3 more pizzas. The change in labor, we went from 3 to 4, it was 1 more worker, so our marginal contribution is 3. And this is really important, and I'll explain why in a bit. But for now, let's just fill in the rest of these. And you can pause the video and do them on your own. But by following our formula, the change in quantity divided by the change in labor, delta Q divided by delta L, we would see that it goes to 1. Look what happens from 6 to 7. Output stays the same. So there's no change. That's a 0. And look at this. When we go from 7 workers to 8 workers, something weird's going on. We actually lose pizzas. We had 15 pizzas with 7 workers. We add the 8th worker. Now we have 14. We actually lost pizzas. You never want to hire that worker when you're in business because you never want to have to pay labor costs and lose your money. So in this case, it's going to be -1. So what we've done, my friends, to recap is we have put together a production function. We know we're adding variable labor to fixed capital. We're seeing what the output's doing. And what I want to point out now is this output, which we see in the marginal product column, it really has 3 regions. And these are the 3 regions of short-run production. Every company in the short run is going to face these 3 regions of production. Let's analyze them. Let's start first with right here. Notice that for workers 1, 2, and 3, as our labor goes up, our marginal product goes up. In other words, each extra worker from the first to the second to the third is contributing more pizzas than the one before. The marginal value, sorry, not value, forgive me, the marginal product of each worker is growing. We call this region in production theory the region of increasing marginal returns, because each additional worker is generating additional pizzas. Okay. Now let's take a look at this. Starting with worker 4, something happened. Worker 4 is still contributing pizzas. Worker 4 is still bringing us 3 extra pizzas. So that's good. But notice that starting with worker 4, and in fact going all the way down here to worker number 7, each worker is generating fewer pizzas than the one before. In other words, workers 4 and 5 and 6, they're still generating pizzas. They're still contributing pizzas to your shop. But each extra, each additional, each marginal worker is contributing fewer pizzas than the one before. So in this region, as our labor goes up, our marginal product falls. This region is what we call in economics the region of diminishing marginal returns. This is the really, really critical rule in production theory. At some point, and it's going to vary with industries and with companies, but at some point, every firm will reach the diminishing marginal return point. And at that point, hiring additional workers is going to reduce the marginal product of each. Again, workers 4 through 7, well, 7 didn't contribute any, but workers 4, 5, and 6, they still contributed pizzas. They just contributed fewer than the guy hired before them. So their contribution was diminished. That's the region of diminishing marginal returns. And then finally, we see in this region here, where each worker actually reduces your overall pizza count, this is the region that we call negative returns. So this, my friend, is the production function. It's a really, really fundamental concept, a really important model, especially for business majors to understand, but for all people, but especially you business majors to understand. Because remember, to take back to the big picture, we're looking to maximize profit. And profit is equal to total revenue minus total cost. And total revenues come from the products that you sell. Here in our example, total revenues are going to come from the number of pizzas that you sell. So the quantity number is really, really important. It's half of your profit. That's your revenue piece. The production function shows us that as we add more workers to a process, we're going to go through predictable changes in our total product and our marginal product. And that's going to be very important when you, as a business owner, decide how many pizzas, in this case, how much product in general to make. Real quick, a couple of questions here. We said, what are the missing marginal product values? Well, we already got those. Identify the 3 regions of the production function. We got those. With which worker does diminishing returns begin? Well, we see that diminishing returns kick in right there. So that's going to be with the 4th worker. With which region, or I'm sorry, with which worker does negative returns begin? We see negative begins when it goes negative. That's going to be the 8th worker. Final question, how many workers should this firm hire? We don't know, because remember, our goal is not to maximize output, but to maximize total revenue. So to answer that question, we have to extend our analysis and move from production, which is the output side, to cost. And that's going to be our next video. Thanks, friends, and I'll see you in a minute.